All right, everybody. We've started, and I'm recording, and I've also just gone live for this one. All right. Now, here's the first question which we're going to look at. We're going to be doing a run for the next few minutes, and I'm just going to be moving, explaining, and making sure you are good. Making sure you are good at all the 4 transformations. So we know that we have 4 transformations. We have translation. We have reflection. These 2, very easy. Then we have rotation. And we have enlargement. Yes. Well done. So these are the 4. Now, let's go for it. So you get a question in the exam. This is you. You're in the exam. You get this question. Of course, the first thing you do, you answer the question which says describe. You know that transformations, they'll either ask you to draw or they'll ask you to describe. So we always start with the describe. Then we'll come back and do these ones here. They want us to draw here. Where they say enlarge, rotate, reflect, it's just drawing. So we start with the one which says describe. Describe that maps P onto Q. Oh, so we don't have P and we don't have Q. So anyway, we cannot describe. So we can start by drawing because we don't have the things that they want. P and Q, we find them by drawing. So let's draw so that we find them, then we can describe. But if it's not a situation like this one, this is a weird situation. It's a new situation. If it's not a situation like this one, normally they'll say draw, then at the other one they say describe. You always start with the describe. Don't change on that one. Except if the one they want you to describe is not there. P and Q are not there. We only have T. So how do we describe? So because of this one, we will draw first. So let's do the transformations. So let's see how to do all the transformations they want. The first one, enlarge T by scale factor 3. All right. So here is what we said yesterday. When you're doing an enlargement, write this to all those important notes, okay? Important points. Important points. Important points. Point number 1, which we have learned, okay, important points for this chapter of transformations. I want everybody to know important points because those are the ones you use when you meet your own type of question. And you are not allowed to break. You're not allowed to break any rule here. So here's the first point. Listen closely. I would rather have you forget my solution, but don't forget the points. Don't forget the procedure. Don't forget the method, because that's the one you are going to use in your question. And I want to see it. So for the points, here's the important thing for transformation. First one, we are saying start with describe. Start with describe questions. When you are doing transformations, we have 4 types. You always start with the describe question. And it will be at the bottom, eh? So ignore the ones that say draw. Start with the describe. Unless the things to describe are not there. That's the first point. Then we go to the second point, which is going to be for enlargement. Let's talk about it because this is so important. For enlargement, scale factor multiplies distances from center. For enlargement, the scale factor multiplies the distances from the center. Okay, distances from center for each corner. Okay? It multiplies the distances from this. So you're going to say OG, distance from the center, right? Times scale factor will give us the new distance. This is going to be the thing. The original one, which is the shape you have, you multiply by the scale factor, then you get the new distance. let's do it. Let's do it so that everyone, I want, because I know some of you have not yet heard nicely what I'm saying. I'll come back to this statement. Let's do it. I'll be explaining it as we are doing. So listen. Locate for me the center of enlargement, please. Because everything to do with enlargement is going to be coming from the center. Everything you're going to ever do is from the center. If you don't start at the center, we have a major problem. We will have a major problem if you don't start at the center. Isn't Matida? So listen. Let's start at the center. Where is this center here? Where is it? It's 0 in the x, 2 in the y, because it's x and y. So you go on the x-axis. Here is your x-axis, and you're going to do 0. Right. So let's go 0 on the x. It's here. Then let's go 2 on the y-axis. It's here. Okay. You go up along 0 on the x until you get to 2 on the y. That's going to be here. So this is the center. This is the center of enlargement. So everything which we're going to be doing is going to be based on him. So now what we're going to be doing is this. Let's take this first point. Okay, we can take any point we want. We're going to be moving. Let's just call it A. Okay, for the sake of. Now, tell me what is the distance from A to the center. Tell me the x, then you tell me the y. So the x distance from A to the center. What is that distance? It's 3 steps, and it's 3 steps going in the left, going in the left direction. So that means it's -3. This is the distance from A to center in the x. If you want the new distance to get to the new A, you take this distance. Distance from center here, distance is the one you multiply by scale factor to get the new one. Because we know that you don't know where the new shape is. You don't know. The only way to know is find the OG distance. What is OG distance, sir? It's the distance from OG shape to the center of enlargement. So that distance here is -3. When you find that distance, multiply it by scale factor. Multiply that distance by scale factor. Your scale factor is 3. So you're going to say, what is -3 times 3? You get -9. So the new one is going to be -9 if we talk about it steps. Or we can say, instead of that, we can say, let's start at the center and get to A. We go 1, 2, 3. So that will be 3 steps. We can say if we are starting from the center, it's better to start from the center. If we are starting from the center, it's +3. And we take that +3, we multiply by the scale factor. The scale factor happens to be 3 also. So we multiply by 3, we get 9. So that means to go to the new one, move 9 steps, okay? Move 9 steps. So you're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So here is your new point A. You call it A prime. Then you can remove. You'll be doing this with a pencil. So find distances to the center. That's all you got to find. And after you find every distance, multiply by scale factor. Find distance from the center to that point, then multiply by scale factor. Find distance from the center to that point, then multiply by scale factor. So we want the next one here. We'll call it B. We want to know where the new B is because we do point by point by point. So we are now at point B. We want to find where the new B is. What do you know? Move from the center to that point B. Let's go. How many steps in the X? 1. Okay, and it's to the right, so it's 1. Then how many steps from the center to B? You go 1. You go down 1 step. You go down 1 step, so it's a -1 in the Y. So, lehakwa, watch your mic. So it's a 1 in the X, then it's a -1 in the Y. It's 1 in the X, then -1 in the Y. So we take this 1 in the X, we multiply by scale factor, which is 3. So we will now get 3. Then we take this negative 1 in the y, because we went one step downwards. We multiplied by 3, we'll get negative 3. So that means it's now 3 in the x, then y, it will be negative 3. So 3 steps downwards. So we can erase. We will now say to go to our new b, we go 3 in the x. 1, 2, 3. That's 3, right? Then 3 downwards. 1, 2, 3. So it's going to be here. This is going to be where b prime is. No way, sir. That's not true. It's true. The new b is going to be here. That's b prime. Okay? That's how you do it. Now, let's remove a prime and b prime. Now, let's work with this last point, c. Let's work with this last point, c. We're doing the last point, point c. Let's work with it. Where is it? Because that is what we will multiply by scale factor. Its distances. Where is it? We'll go 1, 2, 3. It's 3 in the x. So it's 3 in the x. Then where is it? It's one step downward. So it's to be a negative 1. Let's take those distances, multiply them by scale factor. So you say scale factor is what? What is the scale factor? It's 3. So both distances, we multiply them by 3. So here we say times 3. Then here we say times 3. What's 3 times 3? It's going to be 9. Then what is minus 1 times 3? It's negative 3. So that means in the x, it is going to be 9. In the y, it's going to be negative 3. Let's do that. Let's do that. We go in the x 9. 1, 2, 3, 4. You don't count the original one. No. The first one here is 1. After, okay, you move one step. Then, so it's 1 here, then 2 here, then 3 here, then 4 here, then 5 here, then 6 here, then 7 here, then 8 here, then 9 is here. All right, so 9 is there. Then how many steps downwards? 3 steps downwards. So we start from the next one, okay? You don't count where you are. You count the first step down. So we are here right now. So 1 will be here, then 2 will be here, then 3 will be here. So it's going to be here. So this is going to be where the, and that is going to be C prime. Then join them. You have your new shape now. So you do this. Then you join here. Then you join here. Excuse me. Then you can remove. We have the new shape. We have found the new shape. We have found the new shape. So, sir, what is the secret? What is the secret for enlargement? What is it that we must always remember? For 19 years from now, if anyone comes with an enlargement question, how do I remember? This is how you remember. For enlargement, the scale factor multiplies distances from the center. So if you want to know where the new shape is, then find distance from the center for that point. So take a point, find its distance from the center. So you start at the center, you move until you get to that point. You see here it's 3. Then that distance is the one you will multiply by the scale factor to get the new point. If you forget that part, then I don't know what you want to remember. This is the secret. The steps will save you. In an exam, you get a question you have never seen. Do the steps, please. If you get an enlargement, they ask you to enlarge. Go to each point, find its, first put the center. Then start finding each point from the center, its length. Then you multiply them by scale factor. You find the new one. Then join those new points. You will have the new shape. Now let's do the next one. So for enlargement, have you written the important points? Have you done so? Okay. Well done. Now let's go to the next thing. I'm a happy man. Let's go to the next thing. So here we have it. They didn't tell us to label it anyway. Now they say rotate. So we know how to rotate. Let me take, for us to rotate, we have to go to a different board. Let's go and rotate like we did yesterday. We did rotation. This is where a lot of people may have problems. Let's make sure all of you don't have problems. So let's go and rotate. Wait. They say to rotate by 90 degrees clockwise. Let me take a screenshot. Then I'm going to crop. Then I want to go and do this question, which says rotate. Let me switch off the Wi-Fi on this device. We needed to stay with power until the end of the lesson. Please, I want to see this in the work I give you. I'll be the happiest man ever. Ever. I will be the happiest man ever. If you people are so good at delivering the things we agree on, whatever we agree on, if you do exactly that, I'll be so happy because I know you'll be fine. Nothing will catch you in the exam. I know that. So now let's do this one. Rotation. How do we do a rotation? So we've seen an enlargement. For those who, let me stop the recording here. All right. Then start a new one. All right. So I've started a new recording so that I separate them. I post them separately on the side. Those who will be forgetting how to do an enlargement, you just go and watch that video. Now we are covering how to do a rotation. We kind of did it yesterday. We'll do it again. Rotate T about 4 to 90 degrees clockwise. So Simon, where is Simon? Simon, this is the type of question you were asking yesterday. Are you there, Simon? Simon? Where is Simon? LGK, can you check on your friend, please? Yes. So yesterday, Simon had said, sir, how do we do a rotation if we are not rotating from 0, 0? We are rotating from a different point. How do we do it? So rotation is just like enlargement. It has a center. And everything you're going to do will be related to its center. Don't ever do anything and doing it not from the center. You have to do from the center of rotation. So first identify that center of rotation. Identify it. So let's find that center of rotation. Where is it? It's 4 in the X, then 2 in the Y. Okay? So we go 4 in the X, that's here. Then we see where it meets with 2 in the Y. Okay, 2 in the Y and 4 in the X. They meet at this corner here. So this is our center of rotation here. So everything is going to be from this point. Now, who are we rotating? We are rotating T. So look at the steps. This is the most important thing. The steps. The first thing we did when we are drawing a rotation was we identified the center where everything is going to be rotated from. We identified it. Then the second step is, please tell me the distances for every point from that center. And we're going to write them somewhere. So we do this point here. Let's start with this point here. If we call it point A or whatever. Where is it from the center? It is one step in the X, but it's one step towards the left. So we say it is -1 in the X. What about in the Y? In the Y, it's not more because it's right next to the point. So in the Y, it's 0. So this is the first one. Okay, thank you. Then the second one, please. Let's now do the second one now. Let's do this one. Yes, yes, yes. Okay, here's how. Let's repeat it. So what do we mean by coordinates? What are coordinates? That's the most important thing. If we say 2, 3, what are coordinates? What are they? Coordinates tell you how to get to a point. So coordinates tell you If you want to get to a point, move 2 steps in the x, then 3 steps in the y. That's kind of like what it is. So we want to put coordinates of these 3. But remember, what we are doing is a rotation. It's just like an enlargement. The coordinates, when you are doing an enlargement and when you are doing a rotation, they are from the center. You will be told what center. In other words, where should you start from? Don't start from your own point. You can't start from your own point. For rotation and enlargement, these two have centers. You don't start from your own point. You start from where you are told. So here you are told that the center is at 4, 2. So everything is starting from here. So what we need is we need coordinates. When we are rotating, the only thing we need is coordinates, and we are fine. So let's find coordinates. Coordinates of what? We are rotating T, right? Yes. So coordinates of all the corners on T. Find the coordinates of all the corners on T. Because those are the ones we are rotating. And the coordinates are measured from where? The coordinates are measured from the center. So we start at the center. Okay, don't start here. No, we are not in a graph. This is transformations. So you don't do what you feel like. You do the rules. If you break the rules, you are in serious trouble. So the choice is yours. Common sense will be telling you, Dirayana. But if you do common sense, you are in trouble, my friend. Common sense won't save you. Do the rules. The rules say start from the center. So we are going to start from the center. Let's do this point. Where is it? It's 1 step in the x. But we are starting from the center. We go 1 step in the left. If you move in the left, you put it as a negative value. So we did 1 step in the left. And it's because it's in the left, it's a negative 1. What about in the y? We don't move in the y. We did not have to move up or down to get to this point. So in the y, it's 0. Okay, so we keep this point. We are going to rotate it, okay? Keep it. Keep this point. Be smart, okay? Keep it. We're going to rotate it. Then now, let's find the other one. So this one we are done with you. Now we want to find him. Where is he? We go 1 step in the left, so it's also negative 1. Then what about in the y? We go 1 step downwards, so it's also negative 1. That's how we get to this one. Well done. What about to get to this one in green here? How many steps? It's 1, 2, 3 steps in the left, and we are going in the left, so it's also negative 3. As long as you are starting from the center and you go in the left direction to get to that point, remember, you start from the center. You moved 3 steps in the left, so it's a negative 3. Then how many steps? 1 step downward, so it's a negative 1. Now, these are the 3 important points. These are the 3 important points. So what do we now do? Right, I just want to make sure everybody is with me on the procedure, because the procedure is everything. I don't care, even if we do one question, as long as you have mastered the procedure, you'll be fine. It's not about doing 500 billion questions. It's about mastering the methods. So here, we have seen that when you are doing a rotation, the first thing, put the center. So everybody's going to do it. I trust you. You're going to put the center. Then go to each and every point and write their distances, the coordinates. All right. Measured from the center of rotation. When you are done doing that, you are already on your way to success. You come and you now see, am I rotating 90 degrees clockwise, which is like this, or 90 degrees anti-clockwise, which is like this? So here is where you can make a mistake. Listen. If you are rotating 90 degrees clockwise, you are going to flip this page anti. If you are rotating anti, then you're going to flip the page clockwise. I didn't say the shape. I said the page. To get what you want, do this. Flip the page the way I'm telling you. To get what you want, you have to flip the page the way I'm telling you. So here we want clockwise. Clockwise means the same direction as the watch. The watch goes like this. But we are not going to flip it the same direction as the watch like this. You get it wrong. You are going to flip it anti-clockwise. Are we all together? Because they said, why are we flipping anti-clockwise? The question is saying clockwise. Yes! If the question says clockwise, after you write your points, then flip the paper anti. So we're going to flip the paper. Give me a second. I need to do this. Okay. Scroll down so that we flip this paper. This grid, because they said, let's bring the points, okay? I'm trying to make it look the same way it's going to look on your paper, okay? Right. So, because they said, let me move it down. Because they said clockwise, you flip the paper anti. Remember, this is the other step which is tricky. Master it. Master it. Somebody is listening and will do exactly this. You get 100. You flip, because they said clockwise, flip it 90 anti. So you're going to flip it like this. Good. Then you are going to put all these points, exactly these points, from the center again, but whilst it's flipped like this. Whilst it's flipped like this. What? Yes. So look for -1, 0. Whilst it's flipped like this. Where is -1, 0? Where is it? It's -1, which means it's one step to the right. Okay? It's one step to the right. Then 0, so it's here. This is where there is the first point here. Then the other one is -1 in the x and -1 in the y. So we go -1 in the x, -1 in the y. So it's going to be here. Okay? We go one step to the left, then one step downwards. So it's going to be here. Then the other one we go -3, which is 3 steps in the left towards the left, then -1, which means one step downwards. So you go 1, 2, 3 steps to the left, so it's going to be here. Then one step downwards, which is 1, so it's going to be here. So this is where the 3 points are. Then what do? You join them. Can you see this? Yes, just do this and you are fine. Okay, you flip, then you sketch the exact same points. Then now you can flip your paper back, you get your shape. You are done. You have done the work. So let me do this. For me, I have to be doing screenshots when I'm flipping. For you, you'll be flipping your paper. You are done, eh? You now flip your paper. So let's get ready to flip our paper. So this is for, so I don't want to see anyone who struggles with drawing a rotation. We've said the steps. So now the last thing you do, you flip it back. You have done the flipping, so you flip it back. Okay? You flipped it 90 degrees anti-clockwise? Yes. 90 degrees anti-clockwise? Yes. This is going to be the new shape. And did they say label it? I didn't see. Let's go to the question now. Did they say we should label it? So this is going to be the solution. Have you seen it, everybody? Okay. Everybody, have you seen this? Okay. Thank you. Thank you. Thank you. Okay. Yes, Amanda? Ooh. Okay, check on me afterwards. I'll send you the link, okay? To the lesson. Amanda, let me send you something. Let me send you the YouTube link so that you can try use YouTube. Maybe you can be able to. Let me send it to you. Try this one, Amanda. I sent you in your chat. Good. Try to watch from YouTube. All right, so this is going to be it. Right? This is going to be it. Now, for this one, I've also gone live on YouTube, so you can use the YouTube channel to watch if you want. But for everyone, I want you in the Google Meet so that I can mark your attendance. So stay in here. Right? Yes, Uratila, I see your hand is up. Yes. Okay, to 90 degrees, it's like this. Let's flip together. Let's flip together, everybody. Everybody, let's flip. 90 degrees will be like this. If they say in the question 90 degrees clockwise, you take your paper, then you flip it like this, Uratil. Anti-clockwise, sorry, like this. You see? This is exactly correct. Yes. If they say you are rotating 90 degrees anti-clockwise, then before you sketch, you put the center, you measure your points, then you're going to flip like this. If the question had said anti. Okay? Then when you are done, you just do this to go back to the original one. Do you see? Okay, great. Yes, LGK, ask your question. No, you won't get 180. You get 90 clockwise or 90 anti, okay? Yes. Yes, if you are doing if you are describing a rotation, you can say you can get 180 clockwise. Remember, I said last time 180 clockwise is also 180 anti-clockwise, okay? So you can say 180 clockwise or you can say 180 anti-clockwise. For 180, you can choose whatever you want. Only for 180. You can say clockwise or anti-clockwise. It's exactly the same thing. Only for 180, you can do that. Are we together? All right, good. So this is going to be the one. Let's go and see if they said we should label it. Let's go and see if they said we should label it. We go back to the paper. They said you should label it P. Okay, so I just have to put that. Let me see if this is going to allow me. This is a different PDF reader to the other one I was using. Let's see if it's going to allow me to put the picture on top of the other one. Yay, it's allowing me. So let me crop it. Let me fix, give me 1 second. All right. So this is the new one we have. And they said we should label it what? P. So we're going to label it P. Now they said reflect T in this line. They said reflect T in the line x plus y equals to 6. We don't fear this, eh? We know that this is a meaningless line. There is no line called x plus y equal to 6. Lines are, all the straight lines in the world are y equal to mx plus c, okay? They are y equal to something. So we got to take x to the other side. So it's going to be y equal to negative x, okay? Because it's a positive x. It goes, it becomes negative x. Then there is a plus 6. This 6 is positive, so it's there on the other side. So this is this line. Let's do it. So this is the line which starts at 6. It crosses at 6 here. And if it's y equal to negative x, that means it goes down boxes like this, nicely like this. This is that line. All right, so this is the line. Let's put it, everybody. This is the line, this straight line which goes box to box like this from corner to corner. You just join the corners, but you start at 6 because that's the point where it cuts the y-axis. That's the C. Then y equal to negative x, we talked about it yesterday. This line y equal to negative x, y equal to x goes up box to box like this, like this. Y equal to negative x goes down corner to corner. So this is the line which I'm doing right now. This one. This one. All right. Perfect. So now this is the line which we are reflecting, and they said we should reflect T. Now let's just reflect. Reflection is so easy, okay? Here's how you reflect. So first you put the middle line. This is the line, whatever they were calling it, x plus y equal to 6. We know what it meant. We changed it to this so that the line makes sense. You see, they try to do a lot of things to trick you. So the first thing which I've taught you is that there is no line called x plus y equal to 6. It's absolute madness. You will never understand that line if you leave it like this. Put it, make y the subject. So it should be y alone. It should be equal to everything else. So we had to take the x to the other side. And here it's a positive x. When it goes to the other side, it becomes a negative x, then plus 6. So we now have it in the form y is mx plus 6. So 6 is just the point where it cuts the y-axis. That's all it is. So we had to go to 6. Then y equal to negative x is the graph. So this is the graph y equal to negative x, which we said you start here, then just make sure you go corner to corner, going down. You'll be going down if it's y equal to negative x. If it was y equal to positive x, you just go corner to corner, going up. These are common ones. Now let's reflect t. They said we should reflect t. So anyway, this p is this new shape. Let's reflect t. So how do you reflect? You just look at how you do it. You just do distances, okay? Reflection is so easy. Let me choose a green crayon. You just do this. So you start at this corner. You see it's half a point to the mirror line. So the new position is going to be half a point, half to the corner, but in the other direction. So you just go half in the other direction. For here, where is it? It's 1, 2 to the mirror line, okay, along the x. You just go 1, 2 in the other direction. You have the new points. Can you see what is going on? It's like mirror line just takes a length, then throws it to the other side. Let me explain to those who haven't seen what I'm saying. Just go a distance, then you flip it to the other side. So we started at this thing. We started at this point here. If you want, you can do exactly everything to make it the same. I said, look at how we move. Look at how we move for this one, to see where this point is going to be. Okay. Let's say, let me put a mirror line. Let's say you had a shape like this. Then you have a mirror line like this. Right. If you want to know, this is the mirror line. If you want to know where the new shape is, you take this corner, you just move 1, 2 steps. So it's 2 steps like this. To get the new position, you go 2 steps. 1, 2. You have the new position. You take this one. Let's say it goes 1, 2, 3, 4. To get its new, you just go 1, 2, 3, 4. So it would be now here. That's the new position. Let's say you take this one and you go 1, 2. To get its new position, you start here, then go 1, 2. So it's going to be here. Then you do this. This is reflection. That can't be reflection. Look, the shape is now facing the other side. Yes, that's exactly why it's refraction. Reflection will make it face the other side. So now here it's tricky because your mirror line is slanted. So maybe the best way will be to just use the slanted distances. Maybe that's the best way to use the slanted distances because it's a slanted mirror line. So you go slanted distance, that's half a box. So you just go half a box. In the other side, you have the new corner. You start with this corner. Let's go slanted distance. It's one box. So the new position will be one box in the other direction as well. Okay, going slanted. So it's going to be slanted. It will be one box here. This is the new thing. Then let's say we start at this one. We just go 1, 2. Okay, you move like this. Slanted, yeah? You go 1 step, 2 steps, slanted, which means from here, you also go 2 steps in the other way. 1, then 2. So it's going to be now here. This is where it's going to be, okay? Now here. Did you see what we did? We did slanted. Did you see? Did you see? Class, did you see? If it's a slanted mirror line, do slanted distances, okay? That's the biggest point, I think, from what you must take, is if the mirror line is slanted, we do slanted distances. You get to the mirror line, you see how long did you move. Like here, I moved half to get to the mirror line. So to go to the same point, the other side, I move half. I've found it. For here, I moved 1 box slanted to get to the mirror line. So I'll also move 1 box away to the other way. I have the new point. So the new point is here. Ooh, what have I done to my mirror line? You can now erase. Okay. Okay. You can now erase. Then you start here. How did you go? You went 1, 2 boxes slanted. So from here, you also go 1, then 2 boxes slanted. It's going to be here. So that's going to be your new point. Now you just join like this, then like this, then like this. You have your new shape. Sorry. You have your new shape. Oops, what's going on? I just want to remove the rough work. Come on now. Mirror line should stay. We can even remove the mirror line because we are just drawing. You can even remove it. It doesn't really give you the marks. The marks is the diagrams. They want to see the diagrams. They said you should label it what? Q. So you label it Q. There we go. These are the transformations. We have P, we have Q. Whew. So let me stop the recording and then make a new one. Right. So far on our things, we now know we have a recording. We now know how to do an enlargement. We now know how to do a rotation. And we now know how to do a reflection. You just move to the mirror line, then you move the same distance in the other direction. So these 3 you should now know. Another thing which we saw is they can try to trick us when they give us the mirror line. We should change it to a meaningful form so that we know the real mirror line, so that we can put it and use it. Lastly now, they are asking us this C. Can you see that this, you can do it if you practice? And if you follow the steps, if you don't do your own steps, if you do your own steps, then there is going to be a problem. Obviously, there is obviously going to be a problem. The moment you change from steps and you start do what your mind is telling you, not the steps, you are in trouble. Any move you do, you should provide the reason. And the reason should be the rule. To say, I should move the other direction from the mirror line. That's how you think. You don't say, I think I should. No, that's not how you do it. That's a recipe for disaster. You should stop trusting your mind and you should start trusting the rules. Stick to the rules, no matter what. If you have forgotten the rules, you should actually ask me, sir, by the way you said, what is the rule when we do a reflection? That's a sign of a person who will handle any question. I'll be so proud. I know you can handle it because I know deep inside you, you have the rules. So no matter where you go, when you get a question, you calm yourself down, you look at the question, then you start applying the rules step by step. Now let's see here. Describe the transformation P to Q. That maps P to Q. So we want to start at P, go to Q, and describe. Right. Now, don't change the steps. The steps that I told you yesterday, and I'm saying it again today. As long as it's a describe question, the only way to know what transformation it is the first thing. Look at the marks. Look at the marks. The marks will tell you. If it's 2 marks, then there is no way it's a rotation or enlargement. Rotation and enlargement will never give you 2 marks on describing. Never. Impossible. Because they have a center which you must find. So that makes it 3 marks. Because the other mark is finding the center. So rotation and enlargement, you are out of the picture. I'm not even thinking about you. This is either a translation or reflection. They said it's mapping who to who. P to Q. So we look at P and Q. And you are going to see that this shape has pinned. This shape has pinned. So because it is pinning, it cannot be a translation. So translation, you are out. Because translation will move the shape exactly as it is. It will never flip. If the shape has flipped, P to Q, the shape has flipped. So it's not a translation. So it can only be a reflection. So you already get 1 mark from just saying reflection. Don't do it your own way. The moment you see the word describe, look at the marks. Look at the marks, student. Look at the marks. If it's 2 marks, then it will either be a translation or a reflection. Then you go to the diagram and you see if translation is possible. If the shape has flipped, then there's no way it's a translation. Because to translate is to move exactly as it is. It will never flip. If it has flipped, automatically it will be a reflection. So that's for 2 marks. So these are the ones that give you 2 marks. For here, if you see a question saying describe and it has 3 marks, then automatically we know it's only a rotation or enlargement. All right, so far you have the 1 mark for saying translation. How do you get the second one? It's to find the mirror line. You have said it's a reflection, right? So find the mirror line. So, how do we find the mirror line? That's the question you have for me right now, right? Exactly. Here's how you find the mirror line. Here's how you find the mirror line. You take the same point. So this point is this one. Okay, everybody can see that. What do you do with it? What's going on now? You take the same point, you join with a line. Then you mark the center of that line. That's the mirror line. Okay, the center of that line, the line which is gonna pass through that center is the mirror line. So the mirror line is this one, which passes through the center. So I don't care which points you use. Use any points you want. This one and this one, you join them with a line. You mark the center. Then you draw a line which passes through the center. That line which passes through the center should be 90 degrees to the one which you had. So the one which I had is flat like this, which means the midpoint is this one. The one which I want should be 90 degrees, which means it should be vertical like this. So this is actually the middle line. This is the middle line. And what line is this? The line which passes through point number 4 on the x-axis. What line is that? This, because it passes through number 4, it is the line x equal to 4. So it is reflection in the line x equal to 4 because it passes through 4. Okay, are we together? It passes through 4 on the x. If it was gonna pass through a point on the y, it would be y equal to something. So this is a reflection in the line x equal to 4. Is there anyone with a question on this? Students, does anyone have a question on these simple things? If I see somebody not getting correct, I will know the reason. The reason will be you are not doing the steps. Because if you do the steps, I can guarantee you, I know you are going to get it correct. So if I see you not getting it correct, I know the reason. It will be the steps were not followed. Are we together? All right. So I've done this. It's my turn to give you questions. I'm going to give you questions related to the ones I've done. You do them, then tomorrow we go through a nice round of more questions and we finish the chapter tomorrow or Sunday. Next week we're looking at another one. You see, we are doing very well. If we can move at this pace, then maths will be finished in no time. And if you can finish maths, you have created a lot of time. I should stop what? Okay, right first. I'll give you the link to the video, Hami, and then you can write from the video, okay? Is that okay? That's better, right? Good. So what I was saying was, if we can finish maths and move like this, whilst also doing the others, we're going to create a lot of time for a lot of the other subjects. Because if it's maths, I'm okay. As long as it's maths, I'm fine, okay? To be honest, as long as it's maths that we gotta do, then I am fine. That would be an amazing thing. Let me just say this, by the way. Punctuality, people, please. Being late takes away from our time. So try to finish your things at 7 and then be ready for the link. Once the link comes in, you join. And 7:15 we can start. It will help us a lot. Are we together?